Hello students. Now by this video let us study about the chemical properties of ammonia. So first property is ammonia on action with heat. Ammonia action of heat. So when ammonia is heated, it undergoes decomposition. So above a temperature of 500 degrees Celsius, if ammonia is heated, it gets decomposed into N2 and H2, nitrogen, dinitrogen and hydrogen gas. Fine? Yes? So, in the presence of catalyst, nickel and iron, when the catalyst is used and a temperature above 500 degrees Celsius, ammonia is decomposed into N2 and H2. Fine? Now, complete decomposition of ammonia is also possible when an ammonia is subjected to continuous electric sparkling. So, continuous electric sparkling is applied on the ammonia. It is completely decomposed into N2 and H2. No more ammonia is retained there. Complete decomposition takes place. Okay? So here, now let's look at this reaction balance here. Here one nitrogen and here two nitrogen. And here three hydrogen and here two hydrogen. So for that reason, I just give you 3. Yes, and I give you 2. Yes, so 2 nitrogen balanced and 6 hydrogen and here 6 hydrogen is balanced. Fine. So that's it about the action of heat on ammonia. Fine. Now let us look into how the ammonia is reacting with oxygen. So ammonia does not burn freely in air, but it burns freely with oxygen. Okay. So ammonia, when it reacts with oxygen, it gives rise to, it burns completely and forms a yellowish flame. Okay. So this yellowish flame is the nitrogen steam. Okay, this yellowish flame is of nitrogen steam it is. Okay, so when ammonia is reacting with oxygen, it gives nitrogen, dinitrogen gas and water, and this nitrogen gas, dinitrogen, it is acting as, it is in the form of yellow flame, so that is your nitrogen steam. Now let us balance this reaction. So here, near to oxygen atom I just give 3, so here it becomes 6 oxygen atom. Whereas here only 1 oxygen atom, so I just put here 6, so here it becomes 6 oxygen atom. Now hydrogen atom here it is 12, whereas here only 3, so for that reason I just put here 4. Now hydrogen atom is balanced, 12 on the left hand side and on the right hand side also 12 hydrogen atom. Now on the left hand side is 4 hydrogen atom, whereas on the right hand side only 2, so I just put here 2. Yes, so now this is balanced. So 4 moles of ammonia react with the 3 moles of oxygen to gain 2 moles of nitrogen gas. So this gas is yellowish in flame and that is acting as a nitrogen steam. Okay, along with the 6 water molecule. Fine. Now this ammonia can also react with oxygen in the presence of catalyst. Okay, so we know what is catalyst. So catalyst is a substance which increase the rate of the reaction or the speed of the reaction so that the product formation will be fast. Okay. Here ammonia can react with oxygen in the presence of catalyst, that is platinum as a catalyst, and you get nitric oxide NO along with water. So this reaction is used in the manufacture of nitric acid HNO3. So that manufacturing process, commercial manufacturing of nitric acid, that process is called as Ostwald process. Now let us balance this reaction. So I just put here 5 in order to balance. So because it is 5, it here becomes 10 oxygen atom. Whereas here also we should have 10 oxygen atoms. So for that reason I just put here 6. So here 6 oxygen atom and here also oxygen atom is there. So I just put here 4. So 4 oxygen atoms. So 4 plus 6 oxygen atom, it gives you 10 oxygen atoms. So oxygen is balanced. Now hydrogen, it is 12 hydrogen atom here. Whereas here only 3 hydrogen atom. And here 4 nitrogen atom is there. So to balance nitrogen I just put here 4. Now hydrogen is also balanced. Here 4 3s are 12. nitric acid, that is the Oswald process. Now let us look into the next property of ammonia, that is reducing property. So ammonia is acting as a good reducing agent. It reduces metal oxides into metal. Yes, so when this metal oxide is passed, it's heated. Yes, heated and passed over ammonia, then this metal oxide is reduced to metal. Understanding? So here let us look into this reaction. Lead oxide react with ammonia. So ammonia reduces this lead oxide into lead. Along with the lead, nitrogen gas and water molecule is also obtained. Fine. Balance here this reaction. So here it is 2 nitrogen. Here only 1 nitrogen. So I just put here 2. Yes. Now here 6 hydrogen, whereas here already 2 hydrogen. So I just put here 3. So it is 6 hydrogen. Now here 3 oxygen here, whereas there only 1 oxygen. So I just put here 3. Now lead is 3 lead is here. Here only 1. So I just put here 3. So now it is balanced. Fine. So this is the reaction which shows the reducing property of ammonia. So ammonia is acting as a good reducing agent. It reacts with the hot metal oxide. It reduces the hot metal oxide, heated metal oxide into metal. Okay. So lead oxide, while reacting with ammonia, ammonia reduces this lead oxide to lead along with the nitrogen gas and 3 moles of water. Now let us see how ammonia reacts with acid. So when we know ammonia is a base. So when a base reacts with acid, definitely we will get a sand. Okay. So likewise, here ammonia NH3 is reacting with HCl. HCl is hydrochloric acid. So the product what you get is ammonium salt, that is ammonium chloride. NH4Cl is ammonium chloride. So base ammonia react with acid HCl to give the salt, that is ammonium chloride. Okay. So here this ammonia combined with this hydrogen and form NH4 and forms NH4Cl. Okay. Ammonia combined with the HCl and form hydrogen combines with the NH4 and form NH4Cl. Okay. Then likewise ammonia also combined with the sulfuric acid. Okay. H2SO4. So 2 moles of ammonia combined with H2SO4 sulfuric acid to give ammonium sulfate NH4 twice SO4. NH4 twice SO4. So for balancing we just put here 2. So when we put here 2, it's completely balanced. Okay. So this NH4 twice SO4 is ammonium sulfate. S. Now let us look at the next reaction with the chlorine and chlorides. So ammonia react with chlorine and chlorides to give a product. So that product is your ammonium chloride, NH4Cl. So whenever ammonia combined with chlorine or chlorides, yes, so it gives rise to the salt, ammonium salt, that is ammonium chloride. So likewise, here in this reaction we are taking ammonia excess and in another reaction we are taking chlorine excess. Okay, now let us look first when excess ammonia is considered here during the reaction. So ammonia reacting with chlorine. So here ammonia should be excess compared to the chlorine. Okay, so then again you get dinitrogen gas N2, nitrogen gas and HCl, and to this HCl again further ammonia is added and form ammonium chloride. Okay, so now let us balance here. So here 2 nitrogen, whereas here only 1 nitrogen, so I just put here 2. Now here 6 nitrogen is there, whereas here only 1 hydrogen, so to balance that I put here 6. Now here it is 6 chlorine atoms, whereas here only 2 chlorine atoms, so it is 3 chlorine atoms. Okay, fine. Now here ammonia is excess. Fine. So because the ammonia should be excess, so here already 2 ammonia is there. So here 6 HCl we are taking. To that 6 HCl we are adding ammonia. Okay. So when we add ammonia, you get NH4Cl. Okay. So here it is, if it is 6Cl, then here also it should be 6. Okay. So here nitrogen should be 6 here. So this also should be 6. Yes. So now let us see balanced. 6 chlorine, 6 chlorine. nitrogen, 6 nitrogen, and here 6 is 18 hydrogen, 18 plus 6, 24. 24 hydrogen here also 24 hydrogen. So it's balanced. So here in these two reactions, ammonia react with chloride, Cl2. So here excess ammonia we taking this reaction, Cl2. Okay, so ammonia is combining with Cl2 to form dinitrogen and along with that HCl. Okay, 6 HCl is obtained here. 2 moles of ammonia when you combine with 3 moles of chlorine to give 1 mole of nitrogen gas, that is dinitrogen, and 6 moles of HCl. Now that 6 moles of HCl combined with 6 moles of ammonia to give 6 moles of ammonium chloride. Fine. So here ammonia 6 plus 2 8 ammonia is being taken. So excess ammonia is utilized here for this reaction. Now let us see the reaction where chlorine is considered as excess. Okay. So in this reaction, NH3 react with chlorine to give NCl3, nitrogen trichloride. NCl3 is nitrogen trichloride and HCl, and this HCl again combined with ammonia to give ammonium chloride salt. Okay. So in this reaction, chlorine is excess and ammonia is less. Whereas in this reaction, ammonia is excess and chlorine is less. Fine. So this nitrogen trichloride NCl3. Yes. So this is a powerful explosive. Fine. Now let us balance this reaction here. Yes. So ammonia react with chlorine Cl2. Okay. So to balance it, I just give here 2 here. So it becomes 2 nitrogen. So on the right hand side also it becomes 2 nitrogen. Now here it becomes 6 hydrogen, whereas here only 1 hydrogen. So I just balance it by giving 6. Okay. Now here it is 6 chlorine atom, right? 6 chlorine atom. So here it is only 2. So I just give you 6. So 6 2s are 12 chlorine atom here, whereas here it is 6, and here also 6, 12 chlorine atom. Okay. Yes. So now it is balanced. Now hydrogen is also balanced. Everything is balanced. Fine. Now let us balance the second reaction here. So here I just put 2 near to ammonia. So 2 nitrogen. So if it is 2 nitrogen, it is 6 hydrogen. Okay. So here also I put here 2 nitrogen. So here 8 hydrogen, and here it is 6 hydrogen. So one more 2 hydrogen. So it becomes 8 hydrogen on the left hand side and 2 chlorine on the left hand side, 2 chlorine on the right hand side. Yes, and 2 nitrogen on the right hand side, 2 nitrogen on the left hand. So now it is balanced. Okay. So now here the chlorine is excess. So here you can see 12 chlorine atoms are involved. That is 6 chloride molecules are involved. So when you compare with that of ammonia, here only 4 molecules of ammonia is involved in this reaction, whereas here 6 molecules of that means 6 to 12 chlorine atoms are involved in this reaction. So comparatively this is having excess chlorine. Okay. So here when excess chlorine is reacting with ammonia, the product what we get is nitrogen trichloride. Nitrogen trichloride. So this nitrogen trichloride is a powerful explosive. Fine. So when excess ammonia is involved in the reaction with chlorine, yes, you get ammonium chloride. When excess chlorine is involved in the reaction with ammonia, then the product you get is nitrogen trichloride. So which is a powerful explosive. Fine. Now let us see how ammonia react with the sodium. Strong electropositive metals like sodium. When ammonia react with strong electropositive metal like sodium, it forms sodium amide. NaNH2 plus H2. So this NH2 is an amide functional group. So sodium amide it forms. Fine. So now let us balance here. I just put here 2 sodium. So here also 2 sodium. Then it here also it becomes 2 nitrogen. Yes. Now hydrogen, it becomes 4 hydrogen plus 2, 6 hydrogen. So here also 6 hydrogen, so it's balanced. Fine. So sodium, it is a highly electropositive metal. Sodium react with ammonium to give ammonia, NH3, to give sodium amide plus hydrogen gas. Likewise, ammonia can also react with magnesium, the second group element magnesium. So when ammonia reacts with second group element magnesium, it forms magnesium nitride, Mg3N2 plus hydrogen gas. Okay, so Mg3N2 is magnesium nitrides. Okay, fine. So here 3 magnesium is there. Here, so to balance, I put here 3. Yes. So here 2 nitrogen atom is there. So I put here 2. Now 6 hydrogen atom here. Whereas there are only 2 hydrogen atom. So to balance, I put here 3. Fine. So 2 moles of ammonia react with 3 moles of magnesium to give magnesium nitride and 3 moles of hydrogen gas.